afternoon. This is Howard Wiig, Code Green, ThinkTech Hawaii. Very distinguished guest today, Monsieur Guy Akasaki, CEO of Commercial Roofing, one of the larger roofing companies in Hawaii, and very possibly the most progressive company, which is why we have Mr. Akazaki with us today. He is going to explain the connection between cool pineapples and the cool universe. Well, maybe I'll handle that a little bit. The average temperature of a roof in Hawaii, if it's nice and reflective, the way Mr. Akazaki's roofs are, is maybe 100 degrees, and outer space is minus 455 degrees, delta T 555 degrees Fahrenheit. And as you know, the second law of physics, entropy, dictates that hot spots move to cold spots, and more dense to the less dense. So those 100-degree roofs of Mr. Akazaki's just want to get up there into the universe. And that is again achieved by reflecting the surface or the surface of the roof so that it goes right up back to the universe instead of getting absorbed by those nasty old rough dark roofs that Mr. Akazaki no longer offers us to. So welcome, Mr. Akazaki. We're going to talk about cool roofs, cool pineapples, and other innovative technologies that you have incorporated into a pineapple storage facility of all things. We still do have a pineapple industry here in Hawaii. And this is where we're going to see where those pineapples are stored. And if you put harvested pineapples in a hot environment, they ripen too quickly. So we have to keep them nice and cool. So let's turn it over to the great Guy Akazaki. Welcome, Guy. Take it away here. And let's talk about cool pineapples.
Oh boy, cool pineapples. Tell you a little story. When I was in Waikiki, I used to work in Waikiki, and the tourists would always tell me, "Where is that? Where's that fountain where the pineapple juice comes out of that we can take a sip out of?" And I would point them to a coconut tree, and we actually tied two pineapples to that tree. And they go, "Oh my God, they are grown on trees." I'm going to talk to you about cool roofs in the same fashion. What we wanted to do is kind of present for you a project that we recently did, right? So this is a packaging facility in Whitmore Village. It's a pretty big warehouse. You see right off the road, where all the tourists are kind of hanging out to the Malkus side of that sign. But basically, this is where they package it. This is one of our final industries that we have here, not as robust as it has been in decades prior. But they do a lot of the packaging here for the pineapples. This building is a very large warehouse. And basically, what was happening over the decades and the years, this is where they bring all the pineapples to repackage them. The problem with this is it's very hot, and you got pineapples that are very moist and kind of damp when they come out of the ground. You also have a lot of heat thermal movement, right? Hot air rises up to the underside of the ceiling, and they have little vents that basically vent out that. In this in this packaging facility, the pineapples also kind of begin to reek acid. So the material that we actually had put on this roof it's out of Korea. It's called kirin, and it's not drinkable.
Mm.
And it's similar to almost like a SIP, a standard insulated panel, except it's laminated between two preformed metal finishes. Now you think, why on both sides? These panels are generally used for vertical paneling for warehousing, for insulation purposes, and it's great. not too many people. This is probably one of the first installations where this sandwich panels have been used on a roof. And the reason why they wanted to have the paneling on the inside is that prior to this construction of this project, they had the pineapples in there, and the acidity from the pineapples pretty much started to create a lot of mold on the underside of the R19 fiberglass insulation, kind of creating more of a food hazard, created all kinds of mold and mildew type issues on the underside, as well as began to kind of wick the insulation. With that moisture rising and the acidity, began to eat a lot of the C purlins and the J purlins that hold up and support the prior system, as well as eating up the purlins itself. So this system was made with a special coated panel on the underside of this paneling. Basically, it's sandwich. You have a metal preform finish on the top side. You've got the R19 polyiso insulation in between. And then underneath of it, you also have another piece of preform metal. And the preform metal on the underside is basically made so that any of the acidic moisture and moisture that begins to just stick around on the underside, just due to vapor transmission and heat rising, they're able to wash it down and basically rinse it off and not corrode and rust. The top side, it's an electroplated coating, and it has a very high reflectivity. One of the things that Mr. Wiig is very much an advocate of, being able to reflect that. The insulation in itself provides the insulating value, as well as creating a very emissive type of surface where the thermal energy will drop into the insulation and kick back out again. But before it even gets to that, we have the coating that sits on the outside. So in itself, these panels, we tried to run them the entire length of the very top, which is the very point of the roof. Maybe you can move to another photo, the next photo. You can see how you have the big openings, and you can see the purlins that are running perpendicular to the superstructure. And that distance is about 5 feet. So it's quite a bit of distance to be able to span that area. And then we wanted the panel to go all the way down through the end of the eave. That way you have no seams. And again, if you have any vapor drive that occurs as a result of, like the acidity of the pineapples, it's not somewhere where there'd be an overlap and moisture to kind of capture itself. Yeah. So these panels being put on there, we actually had to put them on with a crane. And maybe we can move to the next photo. This is kind of a bird's eye view from a distance perspective. Next one. Oh, my eyes aren't that good. Can you see a crane there? I can't quite
Nope.
see it there. But anyhow, these panels were quite long, and they're about 250 to 300 pounds a panel. So we had to we have cranes that we currently have, and we deployed them to be able to raise these panels, which weighed close to about 250 to 300 pounds. And even at that, as we set them down on the superstructure, it really required us taking 4, 5 guys, 6 guys, to even kind of struggle to move these panels. So it's a pretty dangerous, but yet, very rewarding when it was kind of finished. Move to the next photo. And you can see him moving across. I think that might be a crane there on the left-hand side.
Mhm.
Yeah.
Could be, yeah.
Yeah. So a 29-ton crane. It's not a small guy. Next photo. This is as we're picking up the old one and putting on the new panels. So that we make sure that we follow all the high safety regulations. Next photo. And this you can see from a perspective, the massiveness of this roof, but yet you can see the solar reflectance. Very white. You get on this roof, you'll blind yourself. Next photo. And that's from another view plane from a drone. Yeah, and that's another shot that we had here. So it's a very big facility. After it was completed, we were amazed at how cool it was inside of the facility. Everybody wants to work indoors and not outdoors to collect them. They want to stay inside. And I think that comes close to the end of the photos. Are there any more? Yeah. So Howard, you have any questions?
Oh, heavens, yes. There is zero artificial cooling, no fans, no air
None.
conditioning in there.
No, the only cooling that you have is really the convection when hot air rises through those vents, which is kind of a custom vent, had to be sized for the capacity of the warehouse.
Hmm.
This is actually a three-sided warehouse. Yeah, one side is pretty much open for trucks to go in and out. So
Hmm.
it's a natural form of ventilation. Very nice, except you're venting
Precisely.
acidic pineapples.
Hmm. Hmm. And what would you estimate the interior temperature to be on a typical day?
On the inside prior to, it probably was pretty decent, but I would say when they put on the new panels, it probably got down to probably at the ceiling. Generally, you drop the temperature down maybe 15, 20 degrees. And
Hmm.
that's quite a bit of temperature difference when you come down to the ground.
And then how about at the ground level where the people are? What would that just be ambient temperature or listening?
The ambient temperature, right?
Hmm.
Because you've got a lot of space up to the top.
Yeah. And then you also have, as you say, via convection, you have air movement
Yes. Yeah.
there, which cools us human bodies down. I'm thinking of the comfort level of the people working in that facility.
Definitely from the prior ridge that was there to the new one that was there, it really was conducive. And with the smooth finish on the underside of the panel, it allows the air to seamlessly migrate up to the ridge and just
Hmm.
really drop out into the open air, right? Using hot air
Hmm.
rising. So it's
Yep.
a natural form of ventilation, kind of keeps the inside cooler. Um, it also makes it perform for a much longer time, primarily by them able to washing the alkali that's created from the pineapples off the bottom side. Then superstructure, the pearlings, everything lasts a lot longer. In addition
Hmm.
to the fruit being ready for the market and not so ripe, and also the workers having a much more amenable space to work with. Yeah.
Yeah. So do you actually, not you yourself, although you're probably strong enough to do it, do they actually power wash the underside of
The
surface?
prior system, which had the fiberglass back that generally runs over the insulation, excuse me,
Hmm.
over the purlins before the metal roof is put on top, that you wouldn't wash. Because if
Hmm.
they hit that with a power washer, it would shred it and it would just drop all that fiberglass fibers right into the pineapples. It'd be kind of a little stinging taste in your throat.
Mhm.
Your taste
You
buds.
might get some complaints from the consumers.
Yeah, and I
What
think
is
on
this
the
sticky
underside,
stuff here? Yeah.
right, the underside of the fiberglass insulation was black with mold and mildew. So it's not a
Mhm.
very healthy environment to be in.
Mhm.
Now, with this system, pretty much one of the first of its kind, where it was these panels are generally used for the exterior vertical paneling. This was used on the roof with the sole purpose to be able to kind of wash and to rinse off the metal from
Mhm.
the acidity, which has kind of been problematic for that packaging facility.
Absolutely. Yeah, yeah. So what I'm after, of course, is the energy efficiency of this.
Hmm.
We're talking thousands and thousands of square feet here, and you're keeping people comfortable, and maybe more important, you're keeping the pineapple comfortable
Happy
also,
campers.
all by passive means.
Yes. Yeah.
And this is a message that I continually get through to people is that an initial project might cost a few pennies, few extra pennies, but you have all these benefits. The pineapple is happier, so you're going to make more profit out of that. Your workers are comfortable, and this is what we call materials resource. If you can make any man-made object to last longer, 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 you don't have to put in all of those materials and change it constantly. They
Exactly.
last and less and less. So
Hmm. Hmm.
energy that went into that is another form of energy efficiency.
Yes, absolutely.
Yeah.
Absolutely. I'm in total agreement with the what you're saying, Howard, in terms of sustainability.
Hmm.
If you can use passive means, and if you understand the science and the physics of hot air rising,
Hmm.
reflectivity, low emissivity, whatever the means of substrate it may be. As you had shared earlier, how if you have the roof that's pretty much a reflective cool roof, temperature may be ambient, might be like 90 something degrees, which is something reasonable. You can lie down and get a suntan, right? But if you want an atypical roof, a modified bitumen and granite gravel surface, or even a colored shingle roof, and you were to lie down, you'd be leaving half of your skin on the
Yeah,
metal.
yeah, yeah,
I mean,
yeah.
they're about 150 degrees. So you can imagine the amount of temperature, and the kind of havoc that it wreaks on the assembly as well as to the structure itself. And that all ties into life cost cycling and then a life cost performance, right? So as you had said, the reduction of the energy consumption, right? The performance of the construct itself, the life expectancy, and then having systems that are sustainable. Like in this scenario, where by washing it, you don't have to wait till it kind of rots away from the pineapple acidity. So there are things that can be done. Some are old ways and some are new ways in where you can kind of create the sustainability and you can optimize on the passive ability of the sciences in the application of our generation long roofing industry, which we used to know before was those little hot pots that were towed behind trucks and they smelled up the neighborhood and made
Yep.
little black spots all over your cars. Long gone are those days. Long gone.
Yeah, I remember those well. And think of the guys who were in charge of that. That was not the most pleasant job in the whole world.
Very dangerous. Very
Mhm.
dangerous. But with the
Yeah.
advent of technologies and science, there's been a lot of investment, especially in coatings, which I know is one of your favorite topics. And there's so many variations in coatings today. You can buy them in just about every hardware, and everybody would think if it's white, it's good.
Mhm.
Absolutely not.
Yeah, yeah.
you know,
Huge disparity. Yeah.
right? In these coatings, I think it's really important, for people when they look into it. It's not so much the benefits that they say that it can bring to you, as it is understanding the formulation of the coating itself.
Mhm.
Knowing when they say solids, what does that mean to be solids? That is basically the base foundation and the quality of the system. And all of these solids basically come from a few major polymer manufacturers, such as Roman Haas. You've got, what were the other two? There were three other ones that are very large. And basically, what they do is they provide the systems and the testing. And then you have different companies that will bring them to market, and you'll hear their names. I don't want to be taking one over another, but they're promoting it. But basically, what they're doing is just copying the performance of that which is provided by the polymer companies, and then they add a price to it. They have different polymers and quality of polymers in their coatings, and that will also be a benefit to the economic value per gallon as to the amount and capacity of the solids in the material. So there's a lot of moving parts in coatings other than just white.
Mhm. Yeah, you're talking to someone who recently got promoted to be on the committee of the Cool Roof Rating Council.
Oh, excellent! You got a good
Yeah,
man.
yeah, yeah. So you just told me what I'm supposed to be doing there now. And speaking of the solids, I think there's generally speaking, as long as in this case the solids are very reflective material. For instance, titanium dioxide.
Right, TIO.
Correct me if I'm wrong, but the greater the percentage of solids, the more solid the coating is going to be and the longer lasting because I looked at one sample, I think that was 96% solid, and
hmm
a sample that was 70% solid. And what's the unsolid part? I believe that's water. You need to have it moist so that you can spread it around. And
Yeah, yeah.
the higher the solid content, the better the product. But of course, the more expensive the product.
Yeah, you hit it on the head. The solids is basically the foundation of your coating, the quality of your system. So if you go to a paint store A hardware store, you're going to notice there's such big differences in paints and different coatings. And if you look at the solid content, you see variations from 40 to 60. In a hardware store, you may not see anything higher than 50 something. But when you go to an industrial strength, you see 60, you see 70, and sometimes you even have 100% solids. And you're wondering, why the heck is this one so much more expensive than that other one over there? This is
Mhm.
exactly what you're hitting on. It's those solids. The
Yeah,
element
yeah.
that you talked about earlier with the TiO, this titanium dioxide, that's an
Mhm.
additive that they put into the coating. By nature, white coatings, the white pigment is white and it does have its solar reflectance. But just like insulation, where there's an aged performance period, coatings are the same thing. When you first put them down, you go, "Whoa, this thing is so awesome! It's so white." And all of a sudden, 3 months later, you're going, "Whatever happened to the whiteness?" Right?
Mhm.
A lot of it, when you're putting in the right products, such as titanium dioxide, what will happen is that the solar reflectance stays in the formulation a much longer period of time. So
Mhm.
you'll go to roofs, years later, and you'll see that it's still very highly reflective because of that element. And yet, other coatings, it seems almost grayish white. In other coatings, you start to know it begins to pit, right? Because there's a mildew side that's an element that needs to be added to it as well. So yeah, unfortunately in roofing we have to learn to be chemists as well,
Mhm.
which basically
Absolutely.
I barely passed in high school.
Yeah,
And
yeah.
stayed away in college.
Yeah, I just about flunked it, but now I just eat, live, and sleep it.
Exactly.
Yeah. And
Yeah.
incidentally, titanium dioxide is the same active ingredient in a sunscreen.
Yes,
It's
exactly.
white because it has a lot of titanium dioxide in it.
That's exactly right. That's
Yeah.
exactly right. And then in itself, coatings in itself, as you were talking about coatings. I mean, there are different types of coatings. You have acrylics, you have silicone coatings, and every one of them have their applications. I mean, if you're going to do, coding being a very special type of thing and ease of installation, if it's a commercial thing where you never touch it, once you do it, even though you should be maintaining it, um, you might go with a silicone. But if you're on a highly trafficked hospital, commercial building where there's a lot of heat pumps, a lot of servicing, you might want to be a little bit more mindful, primarily in that silicone coatings. They've been around for decades. They've been used a lot for sealants. And it's been about maybe 10 years that they've really kind of made it onto the market as a roof coating. It's UV inert, but if it gets wet, it's slippery like glass, and
Mm.
it's very dangerous. So buildings that have low parapets, a lot of penetrations, we highly ask them to give consideration to what you put down in the execution and operation of your building, not only from the performance of the building, but also from liability, insurance, vendors, et cetera, et cetera. And then the other thing is being able to service it. When you're on a very highly trafficked roof, you have a lot of holes, a lot of cuts, a lot of tears. And when you use silicone coating, they're not the easiest thing. Silicone generally does not stick to silicone. There are some protocols that do, in fact, work. But if you're in a highly trafficked system, it's probably not one of the better ones to kind of look at. There are other systems that are a lot more resilient as well.
Yeah, the first time I got on a silicon roof, I didn't know what you just said, and it was wet. And I suddenly found myself on a ice skating rink, only I was 20 feet above the ground, and the ground was right over there. Rather, it was a
20 feet,
rather spooky
20 feet
experience.
down, right?
I got down very, very carefully. Yeah,
Yeah.
yeah, yeah. But looking at reflective roofs,
Hmm.
have a minute or so to go. They are, in my humble opinion, one of the most effective means of Hawaii cutting down on its air conditioning load, promoting passive design, and
Absolutely.
so much less electricity, which means using less oil that we burn and getting us closer to energy self-sufficiency.
Right. No, no, absolutely. Absolutely. I think right now, you see all the prices beginning to rise. Plywood is now at $110 a sheet.
Mm.
Two by fours are doubling in price. Even in the roofing industry, polymer companies are having a very difficult time being able to get the polymers to make, whether it be the single plies or the different coatings, because of missing, if you could say, rare elements in a
Mhm.
polymer to actually manufacture. So yeah, would there be in prices an increase in that? Absolutely. Unfortunately, technology has its benefits, and it also has its downfall too, right? In terms of
Mhm.
availability. But one thing about the human race, always pretty resilient in being able to understand and then migrate, to something even more beneficial from
Mhm.
a passive and reflective and a low emissivity standpoint.
Yeah. And just finally, I always look at the cost benefit ratio,
Yes.
and I work with a certain industry which will remain unnamed out there. And I say, Howard, your energy code is going to raise the cost of building or housing. And I say, yes, but what are the benefits here? And
Hmm. Hmm.
of course, you have to look at both sides of that. And
Absolutely.
are going to, we're shooting for 100% clean energy. We were the
Hmm.
state to do that, but a lot of other states have joined us since then. And of course, our new president is joining us like gangbusters on that. So this what you pointed to is the wave of the future, ideally passive design to keep things cool and to preserve the life of the pineapple, make a more comfortable environment for the workers, the whole 9 yards. And we do need to close up. Do you have one or two remarks of scintillating wisdom before we go?
Well, I think in Hawaii, we have the aina, we have the air, and we have the sea and the land. And if you can kind of bring that harmony in the assemblies that we bring, so that can be a blending of the two, so that we can have a continuity and leave a legacy for our aina and for the next
Mhm.
generation, that would be a wonderful thing.
Yeah.
And as a roofing industry, hopefully we're trying to do and be a part of that. Thank you
Well,
for the
you're not trying, you're doing, the guy. I congratulate you and all the other roofers who are doing the reflective roof solution. On that very cheery note, we must bid fond adieu to Mr. Akazaki and you wonderful people out there in the audience. Code Green, Think Tech Hawaii. See you next time. Bye bye.